Hi, my name is Rahav Kathori, and this is my constant velocity lab for Physics 2211 and Lab 1. This is my introduction. So the purpose of this lab was to compare the motion of an object moving at constant velocity in real time to a computational model that I coded through a Python program called GlowScript. The underlying fundamental principle that existed throughout this experiment was Newton's second law, or also known as his momentum principle. The following equations, the position update and the velocity update formula, can actually be derived from his momentum principle formula. Thus, we can take a look at the velocity update formula and see that there's an F-net component. Since the velocity is constant in this experiment, we will have no acceleration, which means that the F-net will be equated to 0. Thus, the entire right half side of the velocity update formula should just be 0. Thus, the velocity final should be equal to the velocity initial in this experiment. Here I included an image of my tracker model so you can see what I used for my experiment. I used a water bottle as my system, and everything around it is the surroundings. Thus, the surroundings include the countertop and anything else that came in contact with the system of the water bottle. Here you can see my computational code that I put into GlowScript. The ball.m portion of that was the mass of the water bottle. The ball.position was the initial vector for the position, and the ball.velocity was the initial velocity in the x direction. Obviously, the y components will always be 0, as there was no movement in that direction. The only change should be in the x direction. I also included a while loop to show how fast the program runs, and used this code to print out my graph, which can be seen on the right, which shows a constant velocity as predicted per the experiment. The velocity stayed at 0.340 seconds throughout the entire experiment. And here we can compare my computational model data versus the tracker model data. So the experiment position was generally pretty close to the model position. However, there were some discrepancies, which can be seen around 0.75 seconds and after that. As predicted, the experiment position did slow down and did not keep up a constant velocity due to other existing forces that can be attributed to the surroundings. This could include things like the friction force or just the particles in the air. Thus, the experiment position was a little bit slower than the model position, showing how that the experiment position was modeled in non-perfect environments. So here I will discuss my sources of error further. As I mentioned in the last slide, the friction will obviously be existing, which led to the experiment being slower. There will also be a lot of tracker and human error, specifically when I was clicking the center of mass points on the water bottle. There could have obviously been some discrepancies from point to point. Additionally, any other outside force will also create a source of error and slow down the actual experimental model. Things include like the particles in the air, or any air in the surroundings, which would attribute to the error. Thus, now I'll answer my what if question. So if the axis were flipped, the direction of the velocity would change. Velocity obviously has two components, the magnitude and the direction. Thus, the direction would be different than the initial when compared to the other scenario. And then in regards to the position, the water would now be moving in technically in a negative direction when in comparison to the original direction. However, the magnitude would still remain the same between both, as that is not as the magnitude of the velocity is not directionally based. So what does this mean? Obviously, we're not able to determine every single push and pull that results in the zero net force. However, we can find some. In the computational model, obviously the F normal and the F gravity are going to cancel out, and there is going to be no force in the x direction, which would, in a hypothetical scenario, just keep the system moving in the positive x direction forever. However, this is not the case, obviously, in a real life scenario, as there is going to be other forces that act on the system. This could include things like the friction force, which I have mentioned, which results in a maybe a non-zero net force in the real life scenario. Thank you for listening. If you have any questions, thank you.